Hi, I'm Bob. The law of demand states that a fall in the price of a good raises the quantity demanded. It is about the opposite directions of the moves, but not the size of the change. To measure how much consumers respond to a price change, economists use the concept of elasticity. The price elasticity of demand measures how much the quantity demanded responds to a change in price, holding other factors constant. Economists compute the price elasticity of demand as the percentage change in the quantity demanded divided by the percentage change in the price. If the change is tiny, we use the partial derivative notation. And it can be proved that the elasticity can also be expressed in the log terms. The partial log quantity divided by the partial log price. Suppose a 10% increase in the price of an ice cream cone causes the quantity of ice cream purchased by consumers to fall by 20%. In that case, the price elasticity of demand for the ice cream cones is 20% divided by 10%. That is, the elasticity is 2. Because the quantity demanded of a good is negatively related to its price, the percentage change in quantity will always have the opposite sign as the percentage change in price. But what we often care about is the magnitude of the elasticity, that is, the absolute value of the elasticity. So, in the following, when I talk about elasticity, I mean its absolute value. A larger price elasticity implies a greater response of quantity demanded to a change in price. If the elasticity is 0, the demand is said to be perfectly inelastic. It implies that the quantity demanded is extremely insensitive to the price change. The price elasticity of demand for a vertical demand curve is 0. At the opposite extreme, if the elasticity approaches infinity, the demand is perfectly elastic, which means the quantity demanded is so sensitive to the price change that a little price increase will lead to a total loss of sales. The demand curve is horizontal in this case. Between these two extreme situations, there were 3 cases of the demand curves. If the elasticity is less than 1, the demand is inelastic, which means the quantity moves proportionately less than the price. If the elasticity is equal to 1, the percentage change in quantity equals the percentage change in price, and demand is said to have unit elasticity. If the elasticity is greater than 1, the demand is elastic, and the quantity moves proportionately more than the price. When we talk about the price elasticity of demand, we mean an elasticity at a particular point on the demand curve. The elasticity could vary along the demand curve. Take the linear demand curve as an example. The slope of a linear demand curve is constant, but its elasticity is not. At points with a low price and high quantity, the demand curve is inelastic. At points with a high price and low quantity, the demand curve is elastic. We can use the elasticity formula to verify it. We write the elasticity in 2 parts. The first part is the slope of the curve, which is a constant for a linear demand. In this example, it is -1. The second part determines the size of the elasticity. At the midpoint, price equals quantity, so the elasticity is 1. It is unit elastic at the midpoint. A 1% increase in price causes exactly a 1% fall in quantity. At prices higher than at the midpoint of the demand curve, the price is greater than the quantity, so the elasticity is greater than 1. In this range, a 1% increase in price causes more than a 1% fall in quantity. The demand is price elastic. At points lower than the midpoint, the price is smaller than quantity, so the elasticity is less than 1. The demand is price inelastic. A 1% increase in price leads to a fall in the quantity of less than 1%. The demand curve is perfectly inelastic, where the demand curve hits the horizontal axis. It is perfectly elastic, where the demand curve hits the vertical axis. The linear demand curve illustrates that the price elasticity of demand need not be the same at all points on the demand curve. However, a constant elasticity is possible. For a special type of demand curve, the elasticity is the same at every point along the curve. It is called the constant elasticity demand. It has an exponential form like this one. The quantity is equal to the price raised to the power of beta. By taking the natural logarithms of both sides, we can rearrange this exponential demand as a log linear demand. Using the log form elasticity expression, we can easily prove that the price elasticity of demand is equal to the constant parameter beta. Next, let's explore the determinants of the price elasticity of demand. They include the availability of close substitutes, whether the good is a necessity or a luxury, the boundaries of the market, and the time horizon. First, if a good has closer substitutes, it has a higher price elasticity of demand because consumers respond to a slight price increase by switching to its substitutes and purchasing a lot less of the good. Second, necessities tend to have inelastic demands, whereas luxuries have elastic demands. Gasoline is a basic necessity for many people. The price elasticity of demand is low for them because the quantity demanded changes slightly with respect to the change in gas price. But whether a good is a necessity or a luxury depends on the consumer's preference. A good could be a necessity for some people, but a luxury for others. Third, the boundary of the market we are talking about matters. Narrowly defined markets tend to have more elastic demand than broadly defined markets because it is easier to find close substitutes for narrowly defined goods. For example, gasoline, a broad category, has a fairly inelastic demand because there are no good substitutes for gas. Premium unleaded gasoline, a narrower category, has a more elastic demand because it is easy to substitute regular or plugs unleaded gas for it. Last but not least, goods tend to have more elastic demand over longer time horizons. Many studies have examined customers' response to changes in gasoline prices, and they find that the quantity demanded responds more in the long run than it does in the short run. A 10% increase in gasoline prices reduces gasoline consumption by about 2.5% after a year and by about 6% after 5 years. About half of the long-run reduction in quantity demanded arises because people drive less, and half arises because they switch to more fuel-efficient cars. Thank you for watching this video and subscribing to my YouTube channel. See you next time.